All right, welcome to the study hall for June 20th, 2013. This study hall is going to continue the theme from last time, which is the C trap in data sufficiency, particularly common type of trap answer that you'll see. And in fact, that you'll see more and more as you move up the scale of the quant section. So, an important thing. The usual disclaimer we have to give you is this. It's not really a disclaimer, it's an acknowledgement. Except, as indicated, the following problems are from the GMAT prep software. So, and that's the free part of the GMAT prep software. They're not from the paid question packs, because those are also not an OK source. So, except as indicated, that's where the problems are from. Okay. And once more, just as a quick reminder, please remember where to get answers to the multiple choice questions. That's where you get them. You'll see them underneath your name, which again is not Ron, but it's your name. You'll see in letter A, and that'll be the letter options A through E underneath there. Okay, so let's do a problem. Let's see here. How about this one? This is the one problem in today's slide that is not from GMAT. This is a Manhattan GMAT tab problem. So go ahead and give this one a shot. Again, please remember where to find the answers to multiple choice questions. And we'll give you some time for this one. Have fun. The numbers are skewed. What does that mean, the numbers are skewed? The variable names are shifted? Okay, here's what I'll do. I'll just take a partial screenshot of what I see on my screen. And then I'll just post that. It's probably an issue of the sizing of the whiteboard, because that's what I see on my board. But interestingly enough, when your guys' boards are different sizes, or when it's not standardized or whatever, sometimes the elements on the board will actually appear in the wrong place. So let me know if you guys, do you see it better now? You should. You should see a graphic file of what I saw before. Okay, so let's try this again. Multiple choice answers are here. There are 5 people who already have answers to this problem, and all 5 of you are wrong. So keep working on it. And here's a timer. Also, people, maybe you weren't here like 2 weeks ago, but remember that the title of today's session is the C trap. So that should probably tell you something about what is not the answer to the problem. Just a hint. But go ahead and give this one. Again, all 10 people who have answers to this problem already are all wrong. So you need to keep working on the problem. Okay, go for it. Here's a timer. All right, so here we got 40 people in attendance and only about 30 answers to the problem. So here's one of the usual warnings. Remember with the GMAT, it is a test where you have to pick an answer. So meaning what you cannot do is not pick an answer. That might sound kind of obvious, but just remember that you cannot move on from a question on the real test until you have answered it. So you got to get used to this whole idea of guessing, even if you don't have any idea what's going on. But all right, so here are the choices that you guys picked. And this is where it gets interesting. Because okay, and notice there are still 11 non-responses. One of those is me, but that means that there are still 10 people in attendance here who did not answer the problem. And there's also our other staff moderator, Amardeep, so really that means that there are still 9 of you guys who need a little bit of chiding here, I guess you would say. Please notice that. I mean, you cannot not answer the problem. So this is a pretty big group today. So if you are here, please answer the problems. I mean, again, there's only so long we can like wait for everyone to do this, but just remember how the test works. Like on the official exam, you must answer all problems in the order given. So if you are in the non-responder group, yeah. Okay, now let's talk about it. So I've got news for you guys, which is that B is not the right answer to this problem. I mean, B is a popular answer in this case, but it is not the answer. Okay, well, let's go ahead and discuss. So what we need here, let's read through the problem. One thing, we've had a couple of study hall sessions on word problems where we talk about what should and shouldn't you do. And one thing we've talked about is the first thing you should do when a word problem is placed in front of you is you should read it twice. The first read, you need to not think too much about math and just think about what the situation is. And then the second time, you need to start doing some math. So remember, on a word problem, on the first read, just get the situation. Don't worry too much about the math. Yes. Important to separate these steps. Much more on this is in the study halls that are on word problems, but you should always peruse the problem a couple of times. And then once you have the situation firmly in mind, once you already understand what's going on, start doing that. Okay. Now the other thing we should do, we've talked about this in the study halls on data sufficiency, but we want to make sure that we define what sufficient and not sufficient mean here. So the question is, what is the combined value of 2 purple chips and 1 orange chip? So there's your question. So without spending an inordinate amount of time here, let's just make sure we have a definition up there of what sufficient and not sufficient mean. Because I mean, this is the biggest trouble people have with a lot of data sufficiency, is not defining what those things mean at the start of the problem. So remember to define sufficient and not sufficient before you start doing work. Meaning, what does sufficient mean in this problem? Go ahead and tell me in the chat box. Sufficient means that you can get what? Chat box, please. Sufficient means you can get one single value of, someone gave me what, Janine, that's what not sufficient means, actually. Sufficient means you can get one definite answer for the quantity 2p plus n. So, right. Sufficient means that you can get one value for 2p plus n. And what does this not mean that you are looking for? I mean, you mean you are not looking for what quantities in the chat box? You are not looking for p and n. This is going to be another we're going to talk about the C-trap nature of this problem in just a second, which is the theme of today's study hall. But you do not necessarily want or need the individual values of P and N. The individual values. That's very important. So that's what sufficient means. And not sufficient means that you can get more than one value. Means that 2p plus n can have two or more different values. Okay, so let's go ahead and look at these statements. Statement 1, this is where it gets interesting. Statement 1 is kind of a party. Most of you guys thought that statement 1 was insufficient. Anybody have any thoughts on statement 1 in the chat box? BJ says it's sufficient. Hey, why is that? Yeah, it's given that P and N are integers, and how do you know that? I mean, tell me a story about that in the chat box. Like, how do you figure that out? You plug in, purge the GMAT. Your purge the GMAT is giving me numbers, but it make sure you have to not just plug in that set of numbers. It's more about finding others that do it or don't do it. Yeah, there's only one set of integers that does this in the first place, right? And the only way to figure this out is to make a list. So if you, pretty big deal, right? So statement 1, remember that P and N have to be integers. So P and N are integers, positive integers. Or at least not, yeah, because I mean, they're chips with a value. So remember, you can always inject like a minimum of common sense. So you know that P and N are not negative. Like there's not going to be chips with minus value there. So positive, they're the values of chips in dollars, so they have to be positive integers. The thing to know here is that algebra doesn't have any tools for distinguishing between things that are integers and things that are not integers. So that's the problem here. Like, I mean, a lot of people just look at this and they're like, oh, multiple solutions. But not really, because you don't know how many of those solutions are going to wind up being whole numbers, and that's really the key to the problem. So the first point here is that algebra can't distinguish integer solutions from non-integer solutions. So you have to just make a list, and you have to test cases to see whether there's more than one possibility. And in this case, you do have to test cases for individual P and N, because the goal, don't forget the goal, again, is 2P plus N, but there's no simple relationship between 5P plus 7N and 2P plus N. Like, the first thing you should do is look for that, right? You should look at, just to see if there's any simple transformation you can make to the statement. So this is 5P plus 7N is 53. So there's no totally simple relationship to 2P plus N. If there were, I mean, that's kind of a hint for the second statement. If there were, then you would just be able to do something quick. But here you have to test it. So let's see if we can find values that'll do this. So 5P and then 7N would have to be accordingly. So, well, 5P has to be a multiple of 5. So 5P has to be 5 or 10 or 15 or 20 or 25. There's a typo there. I'll fix it in a second. But basically, you know that 5P has to be one of those values in that list, because those are all the 5 P's that you can have under $53. But then here's the kicker, right? Your total has to be $53. So if 5P is 5, then 7N would have to be 53 minus 5. It has to be 48. It has to be 43 here. It would have to be 38, 33, 28, 23, 18, 13, or 8, or 3. But most of these don't work. I mean, the only one of these that will work is the one that actually gives you a multiple of 7 in that right-hand column. So 48 is not a multiple of 7, neither is 43, neither is 38, neither is 33. Oh, 28, okay, hey, that works. We keep it. 23 is not a multiple of 7, neither is 18, neither is 13. Neither is 8, neither is 3. Oh my gosh, look at that. So it turns out on investigation that there's only one possible set of P and N. So like in this case, we actually wind up finding P and N, which some commentary on that here in a second. But we know that P is 5 and that N is 7. Or sorry, that N is 4. So this is definitely sufficient because if we have hard values for P and N, then we for sure have a hard value of 2P plus N. Now notice this part is not in line with necessarily with the goal of not necessarily finding P and N. Meaning in this case we actually do wind up with the individual values, but what's different here is that it's not like this obvious trap answer thing. I mean, it's not clear to anyone at the outset that A is sufficient. So because the fact that you get the individual values is such a surprise here, that's why it's okay. I mean, this is not, if they gave you a situation where it was appearing to be super obvious what you would get, it'd be a different story. But because it's such a unexpected result to get a single value here, that makes this enough of a surprise. Any questions about statement 1, go ahead and put them in the chat box. Notice that means that only A and D are left. If we make our little grid over there in the corner, A, D, and then B, C, E, that means only A, D remains. Statement 2 is a much quicker study here. Someone tell me in the chat box what's going on with statement 2. And notice that statement 2 tells us that 6P plus 3N is 42. So tell me more, factor meaning what? So Daniel says, my guess is you could get a couple of values for N and P. Daniel is right, but notice that it doesn't matter. This is where you have to go. Remember what the goal is, okay, people. The goal is not to find P and N. It's to find 2P plus N. So Daniel says, not wrongly, Daniel says, my guess is you could get a couple of values for N and P, but we don't care. And that's one of the most important things you have to get out of this, is that data sufficiency is specifically all about testing whether you have a focus or not. So just to, not to make an example of Daniel here or anything, but I wanted to point out that this is exactly what the thing is that you don't care about. Because the goal is 2P plus N. So notice if you take 6, as what you guys are pointing out, if you take 6P plus 3N and just divide it by 3, then you're going to get the goal. So even if there are multiple values here, you don't even have to think about it. I mean, if you have a goal that is to find 2P plus N, then you're clearly done here. So if you divide 6P plus 3N by 3, then you get 2P plus N, which is the goal expression. So that's going to be sufficient. I mean, there are different values of P and N in this case, but it doesn't matter because there's not different values of the thing that you want. So that means that both statements are sufficient individually. We already proved statement 1 is. So is that one. So that means our overall answer here is D, like dog. I think only about 2 or 3 of you guys had D like dog here, so that's some pretty good stuff. We haven't actually talked about the C-trap aspect of this, so we'll do that in a second. But let's look at the questions that you guys have here. Let's see. Okay, here's a couple of questions that you guys have. Let's take this to a blank page so that we can write. Okay, there's the original problem. One student writes, how would you decide whether this might, I mean, I guess it depends on what you mean by this. How do you decide whether this might have a unique value? Kind of saying maybe you can tell me more about what do you mean by this? Statement 1. The phrasing of this question is interesting. I mean, I'm assuming you probably mean or, where you wrote and. Because if you wrote, I mean, and doesn't make a lot of sense here, because to me, at least, going with your gut would be the opposite of writing stuff out. So maybe you could confirm, but I think you meant to write or. So, okay, yeah, that's supposed to be or. Well, I mean, remember what the whole point of data sufficiency is. I mean, at least what one of the major points is. Like, one of the main purposes of data sufficiency, especially if you are doing well on the test, is to present problems that most people get wrong. So just think about, I mean, this is actually what an adaptive test is by its very nature. I mean, if you are doing really well on it, then you're going to get problems that challenge people. And so just keep in mind what the consequence of that is. I mean, if you just think about that for a second, you can actually kind of figure out the answer to your own question here. I mean, what this means is, I mean, unless you're scoring at the very, very bottom of the quant scale, which I don't think you probably are. The point is that you should not trust your gut instincts on data sufficiency problems. I mean, this is actually kind of the whole point. I mean, you'll find that there's deliberate misdirection in general. I mean, today's theme is the C-trap, which, I mean, when you look at a problem that is a C-trap, you are going to think as a gut feeling every time that it's C. That's kind of the whole point, is that you don't know that. So, okay, let's see what, yeah, all right. Other questions that you have. Vidita says, can you simplify? This is a question apparently about statement 2. Can you simplify that to get that? Well, sure you can, but why would you? I mean, remember don't lose sight of the goal here. So, like, sure you could, but why would you want to? So make sure you don't lose sight of the goal. The goal is that we want to find a value for 2p plus n. So we're given 6p plus 3n, and we want 2p plus n. I mean, this is what you got to do in your head when you start the problem. You've got to look at it and be like, oh, look, I'm given 6p plus 3n, and I want 2p plus 1n. I mean, once you realize that, it should be perfectly clear that there's no reason to do manipulations like this, because why would you? I mean, all you have to do is divide the given expression by 3 and you're done. And then finally, let's see here. Ramiro, your question is, again, this whole, maybe you just got here, but the goal is not to find PNN. The point is to find 2P plus N, so we don't care. In other words, let's put that on the board. Yeah, so you got it just to make sure that everybody else, I mean, not at risk of being redundant here, like the entire point. I mean, not to exaggerate or anything, but this is the entire point of data sufficiency across the board. The entire point of data sufficiency in general is for this kind of thinking to be wrong. Like, that's why data sufficiency even exists in the first place, is so that people who do not have the right goal will not get the problem correct. So just make sure you know that. If your goal is to have, you know, all of the, if your goal is to find all of the stuff and not just the goal expression, then you're going to be in big trouble. Lastly, let me resize that so we can fit it on the board. I mean, this is, you can't break it down to 3P plus N is 14. So watch your arithmetic here. 6 divided by 3 is 2, not 3. So, all right, there you go. So now let's talk about the theme of today here, which we also talked about this in the last study hall, so we can be a little bit quicker in the discussion of it. But a lot of your instincts when you look at this problem, I mean, you saw that today was the C trap day, so you probably know that it wasn't C, and that's why there weren't too many people picking C. But when you look at this, you might think, oh, hey, 2 equations in 2 variables, and then just pick C. So the deal here, and we talked about this last time as well, but this is a very common type of trap answer setup. So let's make sure that you guys understand how that works. And what I'm going to do is import this from last time. There's 3 aspects of an answer that if all 3 are, of answer C, that if all 3 aspects are present, then it's going to be a trap. So you'll see a graphic show up. If choice C is too easy, if it gives too much information, and if it doesn't use the key math concept, then don't pick it. It's going to be a trap, I promise you. So like here, it's definitely too easy. I mean, you're just looking at it and saying, oh, 2 equations, and you're not doing any work. Just look and say, oh, 2 equations. In other words, you're not doing any work. It's too much information, right? You don't, you're not thinking about the goal expression. So if you pick C, it means that you are ignoring the goal of the problem, which is to find the value of 2P plus N, and not the individual values of P and N. And then finally, it doesn't use the key math concepts. Like in this case, you are just ignoring the fact that these are integers, which is a pretty big deal because it makes algebra a non-entity. So, but if there's any ignoring of the key math in the problem, then there's going to be a lot of trouble there. So you're ignoring the whole integers thing. So, I mean, just knowing this is not C will still not necessarily help you get D like dog, but at least you know the answer is not C or E in So, okay. Any other questions about the problem? If not, we'll move on to another one. There's all kinds of stuff in that question. It depends on how quickly you process things in general. But the one thing that I can say about that, I mean, what do you guys think? I mean, let me put this up for survey says sort of thing. First of all, I mean, let's get rid of those first few words. I mean, because getting a higher score doesn't really have anything to do with being super fast. So, because everybody needs to try to finish the exam. It doesn't matter how fast or slow you are. I mean, or how high or low you're scoring. I mean, you have to be finishing the test, regardless of who you are, where you're from, or blah, blah, blah. Okay, so there's a couple of answers here. Let me quote a couple of people. So the answer that I don't hate here is from Cartagena. Daniel, that's true, but B is not the whole problem. This is a pretty good sense of what's going on here. So, what you don't want to be thinking is what these three people here are writing, where, especially not 1.5 minutes. Why not? I mean, so someone tell me what the 2 minutes is here. Yeah, and Lee, you'll find that, you know, I mean, notice Lee's comment. It took me 15 seconds to get the wrong answer, ha. I mean, that is a ha 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 type of thing, but it's also like a very important observation. Like if you look at it like this, if you're like, oh my God, I have to finish this thing in like way under the average time, I mean, you know what's going to happen. If there's a trap answer, you are going to pick it. Like that's the problem with trying to do these things too fast, is that all of the traps they set for you, you will walk right into that. So not only do you not have to set unrealistic time goals, but if you do, it will probably make your performance worse on the test. But the thing I want you guys to notice on this thing, well, let's do this by way of analogy. So let's be like Mr. Rogers' Neighborhood for a second. Let's talk about time management. Okay. The thing that's interesting about time management is that it is mostly common sense. But again, whenever people think of things as academic, common sense tends to be a thing that is in short supply. So weird, but you know, there it is. Let's talk about time management. Well, let's say you paint houses for a living. So, I mean, people who paint houses are not necessarily the greatest test takers in the world, but they can figure this out. So let's say your painting crew takes an average of 4 hours to paint a house. How long would you estimate for your crew to paint a huge mansion or a tiny apartment? What do you guys think? I mean, the answers here are obviously kind of obvious, but that's the point. How long would it take your painting crew to paint like a giant mansion? Yeah, right? You guys should be giving me, like, I like what Charles answers. It's more time and less time. Like, this should be very obvious, right? But again, people, common sense, it's not there a lot of the time when you take this GMAT exam. The point with a huge mansion is obviously more than 4 hours. So, we don't know how big the house is. Well, it's an average, so it's an average house. More than 4 hours here, clearly. And I mean, more to the point is if you set a goal of painting a gigantic mansion in 4 hours, what's going to happen? You're going to do a really terrible job of painting the house. So finishing the job in 4 hours, you will do a bad job. Or you just won't finish. And then if it's a tiny apartment, you know, this is not going to take 4 hours. If it does, then that means, like, what is your crew doing? I mean, it's, you know, 2 hours of cigarette break or something. So obviously less than 4 hours. I mean, this is not genius, but the point here is that GMAT time management is the same. Like, if a problem is longer, it's like having a bigger house to paint, where, you know, that's on average, it's going to take you longer. So if a problem is long, then you should allow more than the average time. And then if a problem is short, then you should be finished well before the average time. And that's how the average becomes an average. So I mean, one thing about this problem is that it is clearly a long problem with a lot of stuff to read through, and also you have to make a list in statement 1. So you don't have to do this thing in like a minute and a half. I mean, if you do, then great, you know, as long as you're taking your time and doing your due diligence. But the point is that spending more than the average time on this problem is certainly not a bad thing. So, you know, don't try to limit yourself to the average time. And again, I mean, remember, guys, ladies and gentlemen, I mean, you know, if painting crews can figure this stuff out, then you can too. So, there you go. How do you define long? If you're looking for rules, then you really shouldn't be looking for rules. But just look over a bunch of GMAT problems and look how long they are. And then, you know, then get a sense in your head of what does an average problem look like. Like, just glance through a whole bunch of problems and get a sense of this. So, all right. Let's move on to another problem. But remember with time management, yeah, I mean, guys, you don't have to finish every problem in the average time. Okay. How about this? So remember where to get the Joe Huskins. It looks like you have text in your text box. Maybe you're typing something. If you're not, then you might want to erase it. Here's another problem. Remember where to get multiple choice answers. That's where you get multiple choice answers. So go for it. This problem is not as long, meaning that, you know, you should probably be finishing this within the average time. So, boom. Okay, we've still got a bunch of non-responders to this problem, so go ahead and type an answer in the next, like, not type, go ahead and pick an answer out of that menu in the next 10 or 15 seconds here. Thanks. Okay, I think I may not have been on the mic. when I said this before, but there were a lot of non-responders, so I gave you guys an extra little bit of time to answer the problem. Okay, so let's go ahead and take a look at the answers from the class here. Here is what you picked. You picked these things. We have a strong majority for A this time, so that is actually what the answer is, but let's go ahead and talk about it. So one thing that you should notice, again, the theme of today is situations where C is a trap. So what you should notice here is that this is a situation where these three things are all true. Where if choice C is too easy, it's going to appear on your thing in a second. Choice C is too easy, gives too much information, and it also ignores the whole key math concept. Let's make sure that we know what I'm talking about there. So again, this is the main theme of today, is this whole idea of a trap. If choice C is too easy, too much information, and doesn't use the key math concepts, it's gonna be a trap, ladies and gentlemen. So notice in this problem right here, if you pick choice C, let's take a look at what that involves. Well, if you pick C, then first of all, you're just saying, as far as the too easy thing is concerned, well, if you pick that, you're just saying, oh, look, I have K is 5. And then N is whatever 6 to the third is. I have K is 5, and N is 6 cubed. And then you have hard numbers, and you're just going to, of course, there's going to be one remainder if you have one set of numbers. It's too much information, meaning, remember, the goal is not to find K and N. You actually find K and N. This is not the goal of the problem. Because don't forget what data sufficiency is ultimately all about, is setting a goal and sticking to it. And then doesn't use the key math concepts. This is probably the most important aspect of the C trap, is that if you pick C, you don't even have to think about remainders. This is a problem that's asking you for a remainder. So again, it probably sounds very obvious when I put it in these terms, but if you are not thinking about remainders in this problem, then that's trouble. So you don't even have to think about remainders if you pick C. Uh-oh. So you should know that it's not going to be C, and then, in these kinds of situations, it's also not going to be E. For a fuller discussion of that, check out the recording from last time. The short version is, remember, we're looking at a situation where C is the two statements together are very clearly sufficient. In fact, they are so clearly sufficient that it's going to be a trap. So you know it's not E, because E would mean that even if you had hard numbers, you couldn't solve it, which would be weird. So it's not C and it's not E. All right, now that we have that knowledge, notice we are pretty much done at this point. Because once C and E are off the table, you're pretty much done. Because why? Tell me in the chat box. We should still do the due diligence. We should still do the work. But once you know that C is a trap here, there's only one answer that could reasonably still be a thing. Let's see if somebody can tell me why. Yeah, now you just got to look at statement 2. If you have statement 2 alone, then that's definitely not sufficient. Because you're taking any number in the world and dividing it by 5. So you could have lots of remainders there. So that's definitely not sufficient. So that means that B and D are gone too. So, I mean, that means it's got to be A, but we should still do work. I mean, you know, because you never really know these problems, man. I mean, you should have instincts like the ones we're talking about today, but you know it's going to be A. But let's at least do work here. So let me take this problem over to the next page. And let's do A in two different ways. What are two different ways to approach statement 1? And tell me in the chat box, and then more generally, these are the two main approaches to data sufficiency. Yeah, plug in numbers, and then also there's the more traditional approach, right? So the two main strategies on data sufficiency. I mean, remember, when you look at data sufficiency problem, you should have these two main strategies in mind, which are number 1, your traditional algebra type of stuff like that, traditional or algebraic, or what one might call a textbook solution. And then otherwise you have the pick numbers, test cases. Let's just look at both of these really quickly. I'm going to be rocking back and forth here with an equation writing program, so bear with me with statement 1. So what you have here is n equals k plus 1 cubed. So when I say these things, you'll see the equations pop into the window with a sort of small time delay. Statement 1, you have that n is k plus 1 quantity cubed. So I mean, this is a little bit annoying, but you have to. You don't necessarily have to expand it all the way out, but you have to expand it out enough to see what's going to happen here. So this is k plus 1 times k plus 1 times k plus 1. I mean, I guess some people have just memorized how to expand cubes out. But if not, you should take this as far as you need to see what's going to happen here. Like, you should know that this is going to be k squared plus 2k plus 1. So let's do that. K squared plus 2k plus 1. Now at this point, you don't really have to continue expanding it out because you have a goal here, which is to find the remainder when you divide by k, which means that you can pull out all the things that are multiples of k. So I mean, when you multiply this all out, in other words, you're going to have k times a whole bunch of stuff. And you guys can't see the equations? Okay, there we go. Oh, I wish you guys had told me that before, that you didn't see the screen. So, okay, just to make sure we recap, we're on the same page here, because I said these things out loud, but let me just make sure that I narrate them out there. Thank you, by the way. I want to make sure that I narrate these now that they are on the board. These are the things we're looking at here are the two principal strategies in data sufficiency. There's the traditional strategies, which nobody needs reminders of, and then there's testing cases, which everybody needs a reminder of. That's the one thing that people don't necessarily think about enough, is testing cases. So yeah, Puja, that's exactly what I'm thinking, right? You just know that there's a bunch of stuff times k, and then there's going to be a 1 at the end. Because k times all these things is just going to be stuff that's multiples of k. And then 1 times all these things is still multiples of k until you get to the last term. So like when you have this, that has k in it, that has k in it. The only thing that does not have k in it is 1 times 1. So that the red product. So you have basically this equals a bunch of stuff containing k. plus a bunch of other stuff containing K in this color. Plus the red color is 1. So what that means is that the remainder is going to be 1. Because that's what a remainder is, right? It's like how far over and above a multiple are you. So that means that your remainder is going to be 1. That's sufficient. Now, if that doesn't, if you get lost in that kind of approach, or if you don't really know what to do with the algebra, you can just test cases, right? So n is k plus 1 cubed, which means we should probably start by picking. We should start by picking k, and then we can find out from there what n would be by plugging into that formula. So pick n, find k, and then what's the remainder of k divided by n? So if n is, I mean, k has to be greater than 1. I think I switched those. You need to pick k. And then once you have k, you're going to find n, and you're actually dividing n by k. Okay. K has to be greater than 1, so let's start with 2. If k is 2, then n is 3 cubed, which is 27, and the remainder there is 1. If k is 3, then n is 4 cubed. So 3 goes into 63, so that's a remainder of 1 again. When k is 4, it's 5 cubed. 4 goes into 124, so this remainder is still... You can realize that 4 goes into 100 plus 24, so it's going to go into 124. If k is 5, then it's 6 cubed, it's 216. The remainder is going to be 1 again, because if 215 is clearly a multiple of 5, etc. I mean, remember, they don't really give you fake patterns on here, so you should test enough cases to be confident that there's a pattern. I mean, remember that patterns emerge pretty quickly on the GMAT, you know, so... Because one thing that they are not about here is like tricking you with long fake patterns. So like once you get a few 1s in a row here, you should kind of get rid of all thoughts of, oh, maybe it's not 1. You know, like if the pattern is there, it's a pattern. So this is overall A. Any questions about this problem? Again, the main takeaway is what's on this thing. If it's too easy, if it gives you too much information, and you do not use the important math ideas from the problem, you know what the deal is. If you have any questions, go ahead and type them. Otherwise, let's take a look at another one. How about this? Remember where to find answers to multiple choice questions. Okay, we still have a surprisingly large number of non-responders to this problem. So please pick something that is a something. Take another 15 seconds if you have to. Okay, so let's get on with it here. Again, we have a lot of non-responses to this thing, but just remember you can't not respond on the real test. I know I'm being sort of redundant at this point, but you have to pick a thing. So there it is. Okay, so I mean we do have a decent majority of people picking B boy here, but yeah, let's look at it anyway. So remember because we do have a lot of people not picking B boy, so let's make sure that we learn from this problem. The goal is, again, always have a goal when you start out with data sufficiency. The importance of that cannot be overstated. You have to have a goal. So, and before you get started, you should always articulate precisely what that is. So remember, always start by articulating the goal of the problem. So the goal of the problem is how many votes did candidate X get. And I mean, again, what you should expect to not get here is both pieces of information. So the goal is to find candidate X votes, which means that you should expect a situation in which candidate Y might still be an unknown number of votes. So the goal is to get the number of votes for candidate X. So you should anticipate a situation in which you don't necessarily find votes for the other candidate. I mean, again, this is the whole point of data sufficiency, is for you to understand focus and not focus. So you need to be looking for a focused answer. In other words, you should anticipate that you will find what you want and not necessarily find what you don't want. Because, I mean, this is not an accident they make problems like this. Remember what they're doing. And they're making problems that will nail people who are not focused. I mean, because if someone reads this problem and thinks, okay, I need to find all of the stuff, like if their thought process is, I need to find the votes for X and the votes for Y, then they want those people to get the problem wrong. You know, this is not really a let's test percents kind of problem. This is a let's test whether you can pay attention to the point kind of problem. So remember what we said about trap answers. Let's just reiterate. So, maybe the people who picked C, again, are late arrivals to the session, but it's you know, the theme of today's class is C is a trap. So there's a couple people who picked C, which is kind of interesting. So yeah, if C, well, C is too easy, right? Because, I mean, C would give you just percentages of everything. I mean, you have all the percentages of all the stuff. So you can just look at it and say, I know everything. In other words, you'll get hard values for everything in the world. And I mean, the key math concepts here, it's a little bit, I mean, the key math concept is you know, the focus. I guess it's not really a math concept, but you don't have to think about candidate X in particular. So don't pick C on this problem. It's not going to be C, people, and it's also not going to be E. Okay. Well, let's take a look at the statements, right? So, statement 1, let's take this problem over to the next page. All right, fresh page. So, statement 1 says candidate X received 50% of the votes cast by men. And I mean, what'll help here is making organizational devices. It always helps to organize. So let's organize. It's not organize. There's one Z. Okay. It always helps to organize word problems. So let's do that. I mean, let's just make a kind of humble organizational device. Let's say votes from men, and then votes from women, and then let's just say candidate X, and candidate Y. I mean, so this is not the most genius device in the world, but it'll definitely help us stay on track. So, all right, let's do statement 1. And we might as well make 2 copies of that. So there's a second copy of it. Why should we make 2 charts? Maybe sounds like a stupid question, but why? Chat box. What's the point of making 2 of those charts? Anybody? Why am I making this chart twice? And not just once? Because some people are typing. Data sufficiency problems always make 2 organizational devices. Why? Again, I think some people are typing answers to this. But you don't need to write a book here, guys. I'm just giving you a quick summary. All right, there you go. Okay, my chat window was not scrolling down, so I didn't see your answers. Yeah, right. You have 2 statements, and I mean, this is I like the way that Ramiro writes this, because this is really the key idea here, is that each data sufficiency problem is actually not a problem. It's actually 2 problems. So you should be making 2 organizational devices because you are looking at a problem that is not really a problem. It's really 2 problems, right? Because I mean, the point is that they are separate problems. Like when you have statement 1, you don't have statement 2, and when you have statement 2, you don't have statement 1. So there you go. But always make 2 organizational problems on data sufficiency. So in statement 1, we know that candidate X got half the votes from men, so we 624. That means that Y also got 624, because if they each got half, then they're the same number. But then candidate Y received, we don't know statement 2 yet. So candidate Y received 483 votes from women, and then this is just a gigantic question mark. But notice that the goal is what's the total number of votes in that left-hand column. Right? The goal, we don't care about the right-hand column, we care about the left-hand column. So this is going to be not sufficient. In this statement, this time we know that X received 624 votes, and we don't have any idea how many Y received from men. But do we really care? I mean, notice that if you have 483 votes, this is 60% of the total. What that means is you don't have to do this work, because this work would be kind of obnoxious. But what that means is that you know the total number of female votes. Because it's what you just undo that 60%. So the point is to not get lost in this arithmetic, because it's data sufficiency. You don't have to do it. So then this is just whatever 40% of the known total. So these are going to be numbers that you know. I mean, if you actually waste your time doing arithmetic, you will be a very sad person, but you don't have to, because there's a goal. The goal is, like, I can determine this thing or I cannot determine this thing. Don't ever forget that, ladies and gentlemen. So this is going to be sufficient, and we're going to wind up with an overall answer here of B boy. Any questions, feel free to type them in the box. If not, we can probably do one more problem before we have to close up shop. So, okay, I don't see anybody really typing anything. So, how about this? You're welcome, Ankit. I don't know exactly what you were thanking me for, but you're welcome. All right, here is another problem. I'll give you a timer. Boom. Oh, well, you're welcome. There's another problem with X and Y. Okay, let me, sorry, I went to another window for a second. All right, here is the way that this problem is supposed to look. It's supposed to look like this. Again, this is what was on my screen, so I don't really know what the deal is here, but you should all see the legitness now. Okay, go for it. All right. I guess you can take a little bit of extra time here if you need it, because there was that issue with the visualization of the problem. So take another 30, 45 seconds if it's necessary. Okay, let's, there's still about 14 non-responders, but we need to kind of wrap up here pretty soon. So let's go ahead and let's go ahead and discuss here. So again, there are two people whose answer is C, which, folks, remember the theme of today is problems where C is a trap. So among other things, what that will mean is that the answer is not C. But anyway, remember the qualities of a trap C answer, as we wrote on the other slides. Let's import that little graphic. Okay, there it is. Okay, so choice C is too easy, gives too much information, and doesn't use the key math concepts. Well, I mean, the goal here is just to find the average of all the houses. What is not the goal? Like, what things are we not trying to find? We're not trying to find X and Y. I mean, as trivial as it sounds, it's the key to the problem here, right? So it's true also, Katakana, you don't have to calculate the actual average, but at least you should be able to. I mean, the point that I'm asking about here with X and Y is that you don't even have to be able to find those. Like, that's not even like a thing. Okay, so the goal here is to be able to find this average. Notice equally importantly that the goal is not to find X and Y individually with a bunch of exclamation points. The goal is that average. That's the goal. So if you pick C again, I mean, it's too easy. I mean, you just get X plus Y. You get X and Y, and then you basically have everything. It's too much information because you don't need X and Y, or want them for that matter. And it doesn't really use the key concepts because you're ignoring the idea of a weighted average. If you just have the actual hard numbers for x and y, then you don't have to think really about how that works. So there are shortcuts for this kind of thing, but let's look at it. Notice if you have intuition about these numbers, you can also shortcut the process of statement 1. So, like if you look at statement 1 here, remember what the goal here is, don't forget. The goal is if there can be 2 or more different average prices, that's not sufficient. If there can only be 1 average price, then that's sufficient. Okay, that's the goal here. Well, let's see. So statement 1 says we just know that x plus y is 36. So you don't have to actually do a bunch of Steve number 2. Let me just go look. That was B, boy. All right. That was an answer for Steve number 2. That was B, boy. Okay, statement 1, x plus y are any 2 numbers that add up to 36. So you can use, if you have a certain amount of intuition about averages, I mean, the point is that you can avoid doing extensive math work here. Like if you have, the point is like if I have x is 35 and y is 1, then the average price is going to be very, very close to 212,000. Because, I mean, virtually all my houses are 212,000. So there you go. Then Will has 2 L's. But conversely, if I have x is 1 and y is 35, then my average is going to be very close to whatever the y price is. Then the overall average will be very close to 194,000. So that's not sufficient. I mean, that's 2 or more different averages. And again, if you have a goal, this is more clear. Like if you have a goal in mind, you don't need to go crazy with algebra here because you can just be like, oh, look, 2 or more possibilities. So just keep that in mind. You have to have a focus. Now with statement 2, I mean, there's a couple of ways. There's 3 ways that you can do this. Let me take this over to the next page. Purge the GMAT, is there a stat for how often? I mean, not really, but if you're doing better on the test, you'll see more of them. I don't know if you were here last week, but I'm going to show you the same slide at the end that I ended with last week, which is a list of these from OG12, and it's solidly like a quarter of all the last 60 problems in the book. It's pretty amazing. So there's a lot of them. Is a short answer to that. A lot of them. Okay, so let's look at statement 2. So there's 3 ways to approach. What I'm going to do is just give you a reference for one of those ways. The first way is to use a shortcut for weighted averages. We don't have time to talk about that right now, but there is a study hall on it. So there's a whole study hall on this. So go ahead and search the archive. So we can't do that right now. It's not time for that. But we could also do algebra. Remember that an average is it's the total of all the prices divided by the total number of houses. So the total, we don't have to keep writing the thousands. So I mean, from now on, everything is in thousands. So that's going to be the total of all the prices is going to be 212,000, which is just 212 for our purposes. 212x plus 194y over x plus y. But then we know that x is actually equal to twice y. So that's going to be 212 times 2y plus 194y over 2y plus y. So the point is, I don't have to do that arithmetic on the top. I mean, that's just some number times y over 3y. And so y is going to cancel out, and I'm going to get a number for my average. So that's sufficient. And I mean, again, notice the focus here. I don't have to do this math because I have a goal of like, hey, do I get a number out of that? So, sure. Lastly, you can test cases. Don't forget that's a thing. I mean, we're sort of running over here, so I need to just sketch this out for you. What you can do is like just try different values of x equal to 2y. So try x is 2 houses and y equals 1 house, and find an average. Try x is 4 houses and y equals 2 houses, then find the average. Try x is 6 and y is 3. Etc. I mean, you'll notice that you'll get the same average every time. So this is going to be sufficient, and so the overall answer here is going to be B, boy. So there it is. All right. So we are sort of over here. By sort of over, I mean we're pretty far over time, so we got to quit. But thank you guys for attending. I'm glad that you guys are getting something out of it. That's good. If you have any quick questions of the admin variety, feel free to throw those at me. And if not, then yeah, I'll see you in a couple weeks. So good night and good luck. So we'll see if I'll stick around here for a minute or two and see if anybody's asking an admin question. And the next session should be after July 4th. So, so I think July 4th is right around the next study hall date. The next session should be on the page already. I mean, I can look real quick. I'm going to go ahead and kill the recording here, by the way.